This multiplication strategy is called the area model strategy. It's technically also the same as the distributive properties, just a different way of thinking of it. It can also be considered partial products, but it's an area model, area perimeter. So we want area to help us do our multiplications like a way of organizing. So the first thing you need to do when you have your problem is you need to draw a big rectangle. It doesn't have to be like perfectly straight or anything like that. You just need something that you can use to multiply. Is this going to work? Does not appear to have worked. Border. I wonder if I can make it thicker. Weird. Black. Border is black. Well, I'll just draw it freehand. So you want to draw your rectangle. You want to make it big enough that you'll be able to, that's wobbly, right inside your rectangle. This is hard on a computer. I suggest using paper. So I take my first factor and I break it up into its place values. So this 7 has a value of 70, and the 5 has a value of 5. And then I split them apart. I draw a line. So I'm separating this side into 70 and 5. And then I take my other factor and I do the same thing, except I do it along the other side. So I have 20 because the value of that 2 is 20 because it's in the tens place. And then I have a value of 3 for the ones, and I split those apart too. So what I'm left with is 4 boxes. And to do the area model part, I find the area of each of those boxes. So I'm going to be clicking around to find different colors here to kind of help us visualize this. So I'll just do orange. So the first thing I want to do is do my area. Well, actually, it doesn't really matter. I'll do any one I want to do. I'm going to start with 70 because that's the side of this one. And this is 20. Remember that when you find the area, you're doing length times width. So the length is 70, the width is 20. So 7 times 2 is 14. So 70 times 20, we'll start with 14, and then we have 2 zeros to put on the end. So that's the area of this first box. I'll do the next one over here. So I'm going to do 20 times 5. Now, why is it 20? 20 is this side. Well, we know this is a rectangle. Well, it's supposed to be a rectangle. It's kind of wobbly. But opposite sides are equal in rectangles. So if this is 20, then this is also 20. So 20 times 5. 20 times 5 is 100. So I write that in my box. Then I'm going to go on to another box. Maybe a blue color would be lovely. There we go. Let's do 3 and this one. What is this? Well, it's 70 because if this is 70, then this opposite side is 70. So 3 times 70 is 210 because 3 times 7 is 21. Now we just put that 0 on the end from the 70. And then last but not least, I have this final box. And I am going to do green. So I have 3 here because 3 is here, so 3 is also here. 3 times 5 because that top one is 5. So 3 times 5. 3 times 5 is 15. So I have all my parts. And the last thing for me to do is add them all up. So I'll just switch to another color so we don't get mixed up. I'll use this gray. So I'm going to add them up. I'm going to add 1,400 or 1,400. I'm sure listening to my clicking is fun for you. Then 100 plus 210. Doesn't matter what order I do it in because the commutative property of addition says that no matter what order you add, the sum will be the same. And then my last number is 15 from that box. So I'm adding them up, and I'm running out of space. And I can't write down here, so I think what I'll do is I'll just write it over here. So we have 0 plus 0 plus 0 plus 5. Plus 5. 5. 1 plus 1 is 2. 4 plus 2 is 6 plus 1 is 7. And then 1 plus nothing is 1. So our answer is 1,725. 75 times 23, we found it using the area model. So that is another strategy that if you used that during the year and you needed a refresher, that might help you out.